Oh, got it.
Sorry, Ryan, to interrupt. We are recording this webinar for folks that can't attend, and I forgot to hit record at the beginning. So
Please.
we are
I think
officially recording.
Ryan, sorry, this is Paula Kehoe. Maybe turn down your volume. I think it might be too loud.
Oh, I just unplugged my microphone. I'm just using my, hang on one second. I'm using the phone on my computer now. Is it not easy to hear right now?
It's very loud.
Okay. How's that?
Sounds okay. Thank you.
Okay. All right. So insights from San Francisco operators. So Epic Cleantec, we are an SF-based provider of all things on-site wastewater reuse that focuses on deploying water technology solutions into the built environment. We strive to be a one-stop shop for sustainability solutions. We help clients navigate everything from process and system design, MEP design integration, controls and automation, construction assistance, commissioning, startup, and then long-term operations and maintenance. One of the things that we've realized as we've been in this industry is that the water industry is going to move from just a reclaimed water industry to a resource recovery industry. And so as a result, operators are going to have to be familiar with handling these outputs. So at Epic, we're able to recycle safely up to 95% of a building's wastewater to protect and produce these three sustainable outputs of recycled water, soil amendments, and recovered energy from the heat that is contained in the wastewater. So let me just tell you a little bit about my background. I've been working in the wastewater field for 10 years, and I currently hold a grade 3 certification in the state of California. I've worked on small distributed systems in the private sector, as well as in the centralized municipal space. So this has provided me the opportunity to run over 40 different treatment plants and a wide array of technology types. From where I sit as an operator, decentralized wastewater systems and the technology that surrounds that's been around for decades in places like rural communities and remote resorts. And there's a ton of them scattered around the Bay Area. The difference is that we're deploying these proven technologies into unique settings, whether it's a high-rise condo or a tech campus. And so with that, there's some changes that come about from an operations standpoint. You know, one of the things at Epic is that we begin to understand that deploying a piece of technology into a building comes with a lot of uncertainties. And that's why Epic and the folks on this stage are here to help bring the best practices to light and kind of ensure long-term, reliable, safe, and cost-effective O&M. So my role here today is to open the door a little bit wider for you folks so you can catch a better view of what we mean when we say on-site reuse operations. So some of the challenges associated with these systems occur during the design and construction phase. And so due to the nature of these buildings, the systems need to be able to fit into tight spaces with low ceilings. And those space limitations create some challenges even for operators as well in terms of navigating around the pieces of equipment, being able to change out pumps. So those are big factors when one of these systems is being considered for installation. The material selections during design factor in a huge way, especially when it comes to tank consideration. So selecting the right kind of tank best optimizes space and can be a big help for operators navigating that system. Epic operators walk hand in hand with regulatory bodies from the beginning when we make the transition from a piece of equipment that's just deployed in your building to an efficient piece of recycled water tech, and we make that transition seamless. We work closely with building engineers and property managers, and as a result, we understand some of the pain points that are associated with operating and maintaining these systems, and we could probably host an entire webinar just on those pain points alone. But I just want to highlight a couple of those pain points today. So one of the big questions is, how much does it cost to operate one of these systems? The answer is it depends on a number of factors. And let me tell you a quick story. We recently received a call from the vice president of a building management firm that had contracted with us to operate their treatment system. And on this call, he informed us that due to some economic considerations, they wanted to know if there was a way that we could reduce the cost of our operations and maintenance contract. The really cool thing is that we were already doing this in the background by changing chemical suppliers, increasing water production from the system, and engaging with building staff so that we could streamline our operation. And this resulted in significant savings overall for the building. So while there isn't a cost associated with maintaining these systems, we are always working towards efficient operations and strategic partnerships to help us reduce that economic footprint. And I think it's really important from an operations perspective to have those pieces in place, those strategic partnerships with chemical suppliers, those open lines of communication with building staff, so that we can avoid unnecessary trips to site. The second point that I wanted to talk about is labor. And I know some of you might be asking the question, well, how often does somebody need to be on site in order to operate these systems? And again, this is a question that depends on several factors. One of the things that we've learned is that time spent on site is largely dependent on the type of technology deployed and transparent communication. So we provide transparent operations, and that means that we're in consistent communication with the building staff, and as a result, we're able to avoid a lot of site visits that are unneeded. Another thing to note is that we deploy additional technology at our own cost that helps us keep these operations efficient when we're not on site. So literally 24 hours a day, 7 days a week, we have coverage over everything that is happening inside that treatment room. And as a result, we're a lot more efficient in the way that we're able to operate these plants. Another big question that pops up is odor. What about odor? Doesn't wastewater smell? Not surprisingly, this is definitely Gotcha.
Sorry about that, Ryan.
You're good. So there's a thought that all wastewater smells and that those odors will ultimately make their way to the residents. And there's a certain fear that's associated with that for, a building management firm that's considering, the people that are living in that space. Nobody wants to live in a building that smells like poop. So let me just say that, first of all, our design strategies take potential odors into account from the outset. From the very beginning of a project, we're implementing specific designs, and those address any potential odor issues. We also deploy a variety of secondary odor control strategies that mitigate minor odors before they ever leave the treatment room. And a really cool thing that I'd like to tell you is out of the over 1,000 toilets that our water services, we've only had one complaint. And after investigation, that complaint actually turned out to just be a dry pee trap in an unoccupied unit. And so although this was outside of our scope of work, we really worked alongside the building staff and fixed it by running water down the drain. So yes, odors can be a concern whenever you're dealing with on-site reuse, but there's several control strategies that we have and that we use to mitigate them at the source. And I think from an operations perspective, when you have a highly trained operator working on site, they're able to catch those odors before they ever even leave that treatment room, before they ever go down the pipe and enter into a toilet. It doesn't mean that there's not odors associated. It just means that with effective communication and with highly trained operators, we're able to catch those things and deploy odor control strategies right there at the source. Lastly, we have safety. I chose to talk about safety last, even though it's a primary consideration for every operator, because I think it is the most important. I kind of wanted to leave you all with this thought: is the water safe? So safety is the ultimate goal of a successful operation. Every certified wastewater treatment and water treatment operator in the state of California and across the nation has a focus on public health. They have to. It's part of getting certified. So with the systems that we deploy, we have a variety of safety measures that are in place at each of our locations that enable us to monitor in real time the quality of the water that's going out for reuse. So not only are there regulations in place but it's the main goal of each of our site visits. We've learned through many years of experience that backflow prevention, air gap separators, effective chemical dosing, and quality operators help us ensure that the water that goes out to the building is safe and non-toxic and meets and or exceeds the regulatory requirements. So to date, with all of our locations, we've had 0 water quality violations. And in addition to these physical control measures, the sensors, the analyzers, all of the chemical metering pumps that we've deployed in each of these treatment systems, we have highly trained operators that can spot potential issues before they come to reality. You'd be surprised that with a highly trained operator, how quick they can catch a potential problem before it ever even leaves the plant. And that's a real big thing is having highly trained operators on staff to be able to troubleshoot these issues and deal with them before they leave that treatment room. So at Epic, we don't send any toxic water out. Our control measures that we have in place automatically divert to sewer. And I think that's a really big factor when we're deploying these systems is these critical control points. And so what a critical control point is ultimately is once a parameter that is a part of these critical control points reaches a certain level, it will trigger valves and divert water directly to sewer. Sometimes we have to troubleshoot those things, and that's where the highly trained operations comes into play. So there's so many other considerations that we could talk about that goes into a successful operation, such as remote monitoring, alarm notifications, quality parts installed in the system, intelligent preventative maintenance schedules. There's so much more. And each of these enables us to offer a quality product from design all the way through maintenance. And I think that here at Epic, we've kind of cracked the code on operations, and we consistently deliver first-class service through technology, transparency, and innovative thinking. So there's a lot I know that we went through, and I know you guys probably have some questions, so I'd love to take questions at the end if you have any for me. But otherwise, I appreciate your time. Thank you so much.
Thank you, Brian. Fantastic. All right. Now we will have Kathy with ChemSearch come on and give her perspective.
Hi, my name is Kathy Dackney with ChemSearch. I've been with ChemSearch going on 18 years. My official title is wastewater and water treatment specialist, and I've been focusing on reclaimed water systems for about 10 years now. My role in these buildings is I act as the treatment system manager for these reclaimed water systems. And ChemSearch, we're a 100-year-old company. We have reps like myself in every major city in the United States and all over the world, actually. So I guess I'll just dive right into it. I apologize. I'm usually a field rep, so my Zoom presentation skills are not the best, but I will do my best. So I'm going to share my screen and okay, hopefully you guys can see that. Let me know if you don't. So I'm basically just going to talk about what I have run into or learned over the 10 years of working with reclaimed water systems and how I can see these systems being either built or designed better going forward. So I guess just to start off with, power control panel system being down should not affect end use supply. And what I mean by that is if I have to power the system down when working on it, whether it be for maintenance, filter changing, working on wires, changing fuses, I have to basically stop the system or turn it off. And when I do that, many of my buildings are unable to flush toilets. And it is not a good thing, especially when some of these buildings have high clientele. And if they can't flush toilets, then they're going to get complaints, and then those complaints are going to roll back to me. So I feel like there's definitely a solution to this, and I'll kind of go over what I feel. All systems should be required to have diverter valves, whether it be a manual valve or automatic valve. All the systems should have the capability to bypass to domestic water with the protection of the backflow. And when you do that, then the city water pressure would be enough to send water to the toilets. However, keep in mind, if you have a very, very tall building, you would also need a separate booster pump station with a separate control panel or VFD that does not rely on the rainwater system at all. Because if you had a separate booster pump station, but the power was still connected to your reclaimed water system control panel, and if that went down or if you had to turn that off, then you still wouldn't be able to flush the toilets. One example I have is that I have a building where I can bypass and use the domestic water, but the city water pressure is not enough to get up to the 5th floors and above to flush toilets. So that's not good as well. The ideal example is I have a building where it works perfect because there's an automatic, normally open motorized ball valve. In this case, it's a Belimo brand on the domestic water side. Meaning if the motorized ball valve gets no power for any reason, it will normally open to allow the domestic water side to supply the end use. So that would be ideal if, you know, all the buildings were able to do that. You would think they would be. You would think like if I was working on the system or if I had to turn the system off, that all the buildings would be able to have their end supply, usually flushing toilets, receive water from the city domestic line, but they do not all have that, that option. For some locations, the issue is the programming. And what I mean by that is, I'm just going to use examples. One of my buildings, there's no need for a second booster. It literally has a separate booster system with a separate control panel. It's just the programming prevents the booster pump from running if the system is shut off or down for any reason. Because the booster pump does not know what level the day tank is, so it won't run. It basically relies on the communication from the program to tell it to run. So in that situation, I guess a possible solution would be for that booster pump system to have its own tank level sensor to know if it has water in the day tank to use. But again, it's going to add another layer of complexity in regards to the programming and wires and whatnot. But I'm just expressing what I feel could be a possible solution. But the main issue is that if the system is shut off, turned off, loses power, a lot of these buildings cannot get water to flush their toilets. So there has to be maybe a standardized solution in regards to how these systems are built so that we can ensure that they'll have city water flowing to their toilets or their end use and not rely on the reclaimed water system. And in regards to programming, so flow totalizers. I feel like the information storage registers in the PLC should not be affected by a power outage. What I mean by that is if a system loses power, if the building, say shuts off the power, they're doing tests on their elevators or fire or whatnot, then the water flow totalizers in the program should not reset to 0. But in some case, it does happen in some of my systems. This is not good because these flow totalizer values are needed to document in, for example, San Francisco, the 12C report, and SFPUC uses these numbers to evaluate these systems. So it's not good when the system loses these values because then nothing makes sense, basically. On some of my systems, when the power goes out, the flow totalizer values are not erased or affected. So they should all be like that. So it's just a programming issue. I do have some systems that when the flow totalizers zero out, I just have to rely on the water meters. But some of my buildings don't have water meters there on where I need to keep track of. So that's something that should be standardized, is that it doesn't lose the data inside the PLC when power is lost. UV systems. I spend the majority of my time doing UV maintenance, whether it be changing bulbs, cleaning UV cord sleeves, or changing them out, or cleaning the UV sensors. And to be honest, it can be a very difficult task, and sometimes, honestly, a nightmare, depending on where those UV units are placed on the skid. So I guess just going forward, it'd be just nice if these UV units would be placed on the skid in such a way where it's just easy for anyone to do maintenance and repair. Pressure release valve. it's kind of a no-brainer. I always need a way to release the pressure so that I can remove the parts for maintenance safely. However, even though it's kind of a no-brainer, I do have one system that there's no way to isolate the UV unit. So I literally have to release the UV sensor, and it just comes shooting out because of the pressure inside the unit, which is not safe at all. So that's just something I always keep in mind when, I guess, designing or building these skids and systems. And in regards to a specific brand of UV, everyone's probably seen the Viqua brand, and I am not a fan, to be honest. I feel like it is more difficult than needed to do maintenance on these units. Again, sometimes it's the location of where it's placed on the skid, but the UV sensor on the Viqua brand in particular is hypersensitive. I have spoken to Viqua many times in regards to how sensitive it is, and they have admitted to me, one rep admitted to me that yes, it is a little too hypersensitive for a reclaimed water application. Because I can put a new quart sleeve in, new UV bulb, new UV sensor, and that UV sensor in the middle can go off in 48 hours. It's just sometimes too hypersensitive. So I feel like there might be some other brands we might want to evaluate more and use more, in my opinion. Tanks and cisterns. When a system is commissioned or the handoff from contractor to building occurs, I feel like it should be required to ensure all cisterns and tanks are pristine. I recommend requiring to clean cisterns and tanks if it is not. Many systems, when I took them over, the cisterns were fouled for various reasons, whether the lids were left open for who knows how long, or just airborne particles and dirt getting in from just the construction phase. But what happens is if these tanks are already fouled in the beginning and we start getting the water in there and we turn the system on, it's just an uphill battle, to be honest. I mean, you're going to deal with high turbidity issues. And again, back to the UV sensor, UV issues, and might as well just make sure these tanks are clean before getting the system started and flowing and testing them and working, because it does cause havoc on the testing and the running of these systems. One idea was, I feel like potable water should go into the main collection tank first instead of the day tank. So during like the summer months when there's no rain and that tank is dry, but it has, maybe like half a foot of water, at least we can prevent stagnant foul conditions. Having the potable water also going into the main collection tank first could possibly help in supplying the end use if the system was down. Locations of cisterns and high temp alarm. All right, so I have one system where when the main collection tank gets too hot, what it'll do is it'll let the water out and it'll allow city water to come in to cool down that tank. Well, they shouldn't have put that tank near hot equipment. So it's right next to the boiler room. And so just kind of a no-brainer, but it happened, right? It got designed that way. So that's something to think about. Systems that let water out in preparation for rain. So I have a system where basically it relies on the forecast. And if it's gonna rain, it releases water. And I just don't agree with it. I feel like what happens if the forecast is wrong, it should just let the water overflow so that we don't waste water in a way. Lastly is roof drains. So I feel like they need to have mesh screens on top of the roof. Even having downspout filters with boom socks and metal screen filters and sock filters and amion filters, in some cases it's just not enough. So for example, if you look at the picture and the one in the middle, that one has a grate on it, but most of them didn't have it. So you have these big, roof drains and all these bird feathers and debris and leaves and particles were getting into the system. And even though we have all the filtering down line, it's just, it was more maintenance than needed. It was harder to, I guess, clean it up than needed. So an easy fix to prevent difficult issues down the line is just put like a mesh screen on top. If you can see on the left, might be hard to see, but there's just like this mesh screen, and it doesn't have to be so fine where it's going to cause flooding on the roof, but it's just an easy fix to prevent difficult issues down the line. And lastly, I didn't put it in the slides, but in regards to media filter, I feel like these media filters shouldn't, the media shouldn't go in to the media filter housing until right before the system is, I guess, going to be used, because the media filter, if it sits too long, it can actually solidify. And if it solidifies, it's really hard to replace, and it's not an easy task. So that's just my little tidbit about the media filters. So that is it. I'm going to try to stop sharing my screen now. And let's see here. So hopefully that made sense. And if any questions, I'll be more than happy to answer it.
Thank you, Kathy.
Thank you.
All right. Our final speaker is Michael with Aquacell. Turn it over to you. I cannot hear you. You appear to be muted. Cannot hear you.
Can you hear me now, Taylor?
Yes.
Okay, great. Okay, sorry. I'm going to go ahead and try and share my screen here. Okay, can you guys see my screen?
Looks good. Thanks.
Okay. So, so Todd is our on-record water treatment manager for the San Francisco area, but he had asked me to do this presentation tonight. So I have extensive knowledge of kind of these working systems and where we've been here now. So I'll hopefully do an okay job with it. So our overview here, this is kind of the pipeline that we're going to go through. I'm going to talk a little bit about the background of Aquacell, and we're going to talk about how we've been in San Francisco for quite a few years now, and how we've learned from our lessons through history and tried to create a design evolution to make everything streamlined and a little bit more on the operation maintenance side, as well as the engineers on site. And for our engineering solutions forward, we're going to talk about a little bit more of our operational challenges, which is kind of why we're all here, and some influent water quality and conditions. And then at the end, I'm going to have a summary of what we went over, and then I'm going to open the floor for questions. So, Aquacell Water Recycling by Phoenix. We are an entity that is a joint venture. Phoenix is located in Louisville, Kentucky, and Aquacell is located in Australia. Australia has vast knowledge of water recycling. They have been doing this for 20, 25 plus years. We decided to bring the technology to the United States through Phoenix as a joint venture, and we've been very successful in doing so. So my name is Michael Kottmeyer. I'm currently a project manager for Aquacell, and I have 10 plus years in the municipal wastewater treatment. So my combined experience is I originally went to Phoenix as a co-op in college, and on the Phoenix side, we do a lot of wastewater and tailing, but I have almost 7 years of experience with Aquacell, where we applied this knowledge that I learned on the Phoenix side and used it on the Aquacell side to create an environment where my engineering background could make sure that our systems were completely optimized and we can grow from a situation where we first had laid groundwork in San Francisco and then built upon that. And down here, Dr. Todd Russell, he has a dual degree in civil environmental engineering. He has extensive knowledge in wastewater operation. He is currently a grade 3 wastewater operator. And he also runs a secondary company who is called System Operation Services, SOS, and he runs a lot of these kind of wastewater plants throughout California, and he's our on record wastewater manager for our system. So our original design, we had no biological treatment, and we, being the first in the game, we really had no idea what was going on for this, but we also collected a lot of data and we learned a lot of lessons from it. As you can see here from our wastewater, from our tanks, we had large tanks. We have a small footprint for our system. However, we had no biological treatment with it. And touching a little bit further on our original system design, we wanted to make the smallest footprint possible. And as you guys know, the way that these systems are designed, we get put in the parking garages where we're shoved in the smallest corner in the darkest place. So we wanted to make sure that we're condensed enough and we are able to fit into that space. However, operationally speaking, this creates, as you can see here on the left side picture, kind of a bad design. So we have a backwash pump at the bottom. We have all our piping work here. If anything were to go down in this system, like a valve or a backwash pump or anything really, it's an expensive repair. And that's what we wanted to kind of get away from. So this is the skid that we have now. This is our new design. And as you can see here, it's open. The previous design, it was almost like a compact van. This is your F1 series race car with open fenders. Everything that you see here now on the left side is the front, is what we consider the front. You have your master control panel, you have your analytical systems, you have your blowers at the bottom. All the pipe work is exposed. There's pipe work in between the frames that you can see there. But if you switch it and look at the picture on the right, you have our disinfection equipment. Everything there with the pipe work is all shown to you, and it's easily accessible when in any situation where if we had a UV system go down, we can easily repair it. If we needed to pull something out, repipe it and repair it, we're right on track to do so compared to what we had in the past. So further touching on that, what we originally started with were large, round polyethylene collection tanks, and collection tanks and holding tanks for that matter. So what you see in the very back there is a 1,500-gallon collection tank. The one in the foreground is a 5,000-gallon distribution tank, which is what we call our clean water tank. And these tanks are very large and they're very awkward to move around. And this created a need for us as a provider of these systems to come up with a new way for contractors to understand and keep up with the schedule of the building without opening up new doorways, leaving walls out, or having the crane be on site for extended periods of time. So what we came up with were our own tanks. So Aquacell creates their own modular tanks, their LDPE tanks. It's about a 10 millimeter wall thickness. And each of these tanks, as you see on the left here with the sizes, you can create them and put them together to make one fully functional tank. And we have found that this is extremely beneficial to our clients and to our customers, because if they have a situation where the crane is coming down, or they have a situation where they need to put walls up and they can't leave them down for those large round poly tanks to come in, our tanks will fit through a doorway, a standard double wide doorway, no problem. One guy can bring the entire unit in. So our current design here now is through those modular tanks and through our open kind of unit here. You can kind of see through this picture. So all of our treatment skids come arrived and they come plumbed and they come completely wired. So the only plumbing that you need through our skids is through the external piping. And the external piping, what I'm talking about in this situation, is from the MBR systems, the biological systems, the gray water tank and the rainwater tank. And you can see here through our new design, the center of the picture where our skid is, there's an open design to where it's easily piped into, and you can have the overhanging piping come over, and then however you need to connect it, it's customer friendly. So touching on now to the operational challenges. The first operational challenge that we really want to touch on is the makeup water control. So originally we had designed an automated control system where there was an automated valve, it was an electronic valve that worked off of a level switch. If the level switch in the treated water tank, which supplies the building, dropped below a certain level, then the automated valve would open, and then you would have water fill the treated water tank. However, we have since, all of our systems that we have installed, we have since changed these over from what we can. We have found that there's a design flaw in it. And the design flaw is if there is no electric to the system in a power outage or any situation, if we have an automated electric valve, then the building would not get water. So we switched over to manual valves. And the way this works is, if you can visualize kind of how your toilet fill valve works, there's an all thread that comes down and it's connected to a ball valve. And the valve, when the water in the treated water tank drops, the ball valve will push down and it will open a valve on the makeup valve. And then when the water level rises, it will close it. It's the same way it kind of activates in your toilet. And then a lot of and some of the other situations that we've seen is to making sure that we have adequately sized drainage and overflows. So what we've tried to do in the past is at minimum is to make sure that the drainage and overflows, the overflow is at least the same size as the influent, if not larger. And the reason why we do this is because a lot of the times we have seen you get some fluctuation coming in from the rainwater tank, or you have a gray water tank, and we would also supply the gray water tank through cycling back with the gray water pump. So we wanted to make sure that all of these overflows were sized correctly. And I chose this picture here to mainly express the equipment removal process and the tank overhead access. So this is going back to kind of what we touched on earlier about getting shoved in the darkest corner of the smallest room in these parking garages. We don't have much to work with. So equipment removal and tank access is paramount in these situations. And if we're on top of a tank, kind of in a picture like you see here, we have a pulley system, which will pull out our gray water pump, which is well over excess of about 100 pounds. And we would use that to pull the tank out, pull the pump out. However, when we would be working on top of a tank, we would notice that there's a bunch of overhead piping and fire suppression systems. And I know a lot of the operators on this call in the seminar right now know that you don't want to bump or get near a fire suppression system, because if you bump it and you set it off, it's going to be a big deal. It's going to be a lot bigger deal than just changing the pump. So this is kind of what we wanted to maybe touch on here to show, adequately sizing the drainage and the overflow and the tank access above. So in a situation like this, what we would request is maybe an access hatch above on the concrete cistern, or on the concrete pad over top. But honestly, sometimes we don't really have that luxury, but we make it work for what we can. And another thing here, so on the left side, you have a picture of a tank access. So the tank access on the left side, although in conception, this tank's access was extremely waterproof. It had a lot of back pressure requirements on it, but however, for our application, this is a gray water tank that you're looking at here on the left side. If we needed to look inside and access it, as you're seeing here, the tank lid opens inward and it would fill with water, and it became a very big job trying to close it up. On the right side picture, what you're looking at is a drainage issue, which we touched on a little bit on the last slide. However, we like to make sure that our systems are adequately processing water correctly and completely optimized. And the way that we do that is we make sure that we have backwashing available and through a frequency that we can do that. But we've noticed that backwashing through our goods, through our disc filters, it would create a splashing incident. So what you're seeing here on the right side is what the building engineers had come up with through the piping diagrams here. So, and when you backflush with aeration and forced water, it's going to spill on the floor. And one of the things that we have noticed is we're trying to determine how we can mitigate the splashing without having what you see on the right. And we've come up with a solution that we're currently rolling out on all of our plants. And what you see on the right side here will no longer be a part of our operation. We've come up with a great solution and we're implementing in all our plants, and it will no longer, and our customers will no longer see splashing on the floor. They'll no longer see any type of gray water on the floor or anything like that. So another thing that we've touched on, or another thing that we've seen in the past is vehicle access, getting into these plants. I know it's really tough getting into a high-rise building when there's a lot of customers there or there's a lot of employees in for the day. And our guys like to carry a lot of equipment with them. So if they're there for a routine visit, it's not much of a big deal. But if they're there to change out a pump, vehicle access is paramount because they want to make sure that they have all the tools right next to the door that they need. And the second bullet point here, internet connectivity, and then chemical delivery and storage and air handling. So internet connections is another one that we are working with. And when you deal with high profile clients that Aquacell by Phoenix has dealt with, you have a disconnection where they want to be completely separate. And it's completely understandable from our standpoint. If it's a cybersecurity company that we're working with, they want to be completely separate. So operational challenges, to access our system and make sure that they are comfortable with our internet connection to where there's no compromisation that can happen. It's paramount. And we've been working with our clients, and I think we've come up with a solution that can make that happen. So chemical delivery and storage and air handling. So what you can see here in the picture on the right, this is one of our installations. This installation here is a situation where the air handler it had enough CFM and enough air changes per hour to push the air out into the parking garage. However, it pushed it out into the parking garage. And then from there, we understood that that was not the ideal situation. So we're working with our customer there to make sure that we can have a solution to where we don't put all the odor control or the odors out into a public space, and it's all contained. So one thing that we want to make sure, and this is paramount for all of the staff at Aquacell and Phoenix, we want to make sure that all of our safety equipment is accounted for. We have chemical showers, we have eye washes, spill kits, chemical hazard labeling, and we are completely in compliance with the fire department and the codes of SFPUC and SFDPH. And a lot of the times that we have seen, and in these designs is we don't really have washdown sinks. There's not maybe a fresh water supply, whether it's coming off of the booster pumps where we can get a hose bib, but we want to make sure that the safety of our technicians that are visiting the site is paramount. That's 100% of what we're looking for. So operational challenges with this is to making sure that the safety equipment, whether it be chemical showers or eye washes or spill kits, is talked about in the conception of these plants, in the design of these plants. So moving forward, we're talking more about the rainwater aspect now. So rainwater systems, you know, anyone who's been doing this for as long as we have, we know you got inconsistent rainfall in San Francisco. The rainfall comes from our rooftops, and you can see in the picture on the right here, I selected this photo because you can see the iron deposits in the water, and you can also see kind of the oily kind of barrier here coming out from the flexible hosing, the float switch. And we've seen what we would really kind of call is what we would see is we have first flush diverters on our plants. And we also always tell the contractors and the engineers to make sure that whenever we have a first rainfall event, let us know, we'll divert it all, because we get a lot of stuff, especially when we first start up a plant, from a lot of construction debris coming down those pipelines. And this is what you can see here in this picture. So we're working, and we have throughout the years mitigated this, but you know, looking at this picture here on the right, it's almost, sadly to say, it's almost a wash, because you have this in your rainwater tank, and we can try and process it, but at this point we would want to flush it first. And we're in the business of water recycling, and that's really nothing that we want to do. So another operational challenge that we have here is the rainwater systems with gray water. So we usually have, if rainwater is involved, it's a concrete pouring cast cistern, and gray water, our systems are on top of that. But the difference in water quality is paramount, what we kind of talked about here with the iron in the water, if they have planters on the roof, depending on what we're getting with the rainwater quality. But the water quality standards that we do try and push for, and what we're required to do, is through gray water. So we're trying to understand and what we have done in the past, and I think we're at a point now to where we do understand it, and our systems are at a point to where we're processing water and we're getting permitted for making these changes, is we understand the rainwater conditions and what they can be, and the gray water conditions and what they are. And we'll touch a little bit more on this on the next few slides, but we want to prepare for the worst and create a system that can handle rainwater systems and gray water systems, but in the worst possible situations. So touching on the influent water quality. So assumed strength versus the actual of what we've seen. So we've seen, and you can look this up in you know, a lot of the documents, and there's theoretical data and there's actual data. And Aquacell by Phoenix has actual data for the past 10 years of San Francisco water quality data. And so you can see here the chemical oxygen demand, these are the highest observed that we've seen at our plants in San Francisco. So the COD greater than 900 milligrams per liter, BOD greater than 500 milligrams per liter, soluble BOD greater than 400 milligrams per liter. And what we have been kind of tasked with, and what we're trying to do, is take these numbers down where it becomes compliant on all across the board. And it's kind of a moving target. However, Aquacell by Phoenix, I think we have figured it out. So one thing kind of that comes with that influent quality is the color of the water. And we've seen, you know, the concrete tank liners, this can be from buried tanks, they can be from the rainwater cistern. Any tank that is cast in place and poured concrete will need to have a tank liner. And what we've seen in the past is depending on when these tank liners are poured, we might get a lot of oil in the system. And the second bullet point there, the rainwater collection systems, what we have seen is if they're on the rooftop and there's a rainwater collection system, they may have a situation where they have planters on the roof where it runs through the system, and you get a high concentration of dissolved solids. Or if they're on the roof, a lot of times what we've seen is they're doing a lot of maintenance on the rooftop, through the HVAC or whatever it may be, and then all of that, what we're trying to collect through rainwater, could come down through our collection pipes. And we touched on it a little bit before, but I think that's kind of what we were talking about, making sure that we have that connection with the engineering team on site to make sure that we are doing the first flush diversion, getting everything out, making sure that all the iron and all of the soot and whatever it is coming down for the rainwater system is flushed out. The next point here is soap suds, showers, hand washing, and eco-friendly products. This is the big one. A lot of times what we would see if we're collecting from showers, especially if it was through a gym or something like that, if you're collecting through a gym shower and maintenance comes through and they go to clean it, they're going to use a lot of cleaners that may not be eco-friendly and are ammonia-based. They're ammonia-based, chlorination through ammonia-based products. I'm sure a lot of people know on this call, if you as operators, it's not very good. And a lot of times, on the third bullet point we're here, the hair and fibers through shower and laundry. You're in a shower, you're washing yourself. We would get a lot of hair built up in our gray water tanks through these means. And here you go. So the left side is what we're looking at here. This is an investigative project that we did on one of our installations in San Francisco. As you can see, so our collection on the left side picture, all of that you see up there, all of the contamination, the discoloration, that's going straight to our system. And on the right side is kind of the eye-opening factor. This is what you get coming down the shower drain. So it's a lot of hair, it's a lot of shampoo, it's a lot of soap, but this is what we get. And this is what we're trying to mitigate, and what Aquacel and Phoenix has come up with as our new pioneering systems. We've understood this and we've mitigated this to a design to where this is no longer a problem for us. And this is kind of the wrapping it up here. We talked about influent water quality extensively on my portion, but what you see on the left side here is you have a pass-through of a lot of the soap that was used in public showers, and it's made its way to our treated water storage tank. And on the right side, it's made its way to the toilet. And this is an older photo. I don't want anyone to kind of be, in a situation where they're thinking, okay, this is, I hope this is buried, but it is. And we figured out what was wrong with here. And but this is kind of an operational challenge for all of the other operators on the call. You need to understand what is going down your pipes and being introduced into your system. Because if you have a situation, what we see here, going down our pipes, there's really no operational parameter that you can have on our early systems, so that would remove soap. And it all ended up into our treated water tank, and then, as you can see on the right photo, our toilet. So, in summary, we kind of talked about our Aquacel design evolution, where we had a really condensed treatment skid, and we had large tanks. We talked about our operational challenges, where it was influent water quality, our piping diagrams, and constraints through automated valves versus mechanical valves. So this is my last slide here. You have our contact information. Again, my name is Michael Kottmeyer. There's my email address there. Todd Russell, he's our wastewater manager. It's on record. There's his email address and his number. So I think that kind of brings us to the end of my presentation. So, you know, if you guys have any questions for us, you know, I can leave this slide up for you guys can kind of take a picture of it or whatever. But we are 100% willing to talk about it. We are always wanting to make sure that we have the systems that are fully optimized and running as efficiently in San Francisco. And any feedback that we can have from anyone on this call is always accepted. We're always trying to grow. We're trying to make sure that we're a leading competitor out there in San Francisco, and anything that you can do to help us get there. And I know we're all trying to reach the same goal, which is water conservation. And if we can do that in the end of the day, I think we're all in a good shape. So thank you guys for your time. I appreciate it. I'm gonna turn it back over to Taylor.
Thanks so much. Fantastic presentations from everybody. Hopefully folks have time to stay on for another couple minutes. I know we're just past the hour, but we have some good questions coming in. Kathy, the first question's for you. Can you expand more on the normally open valve on the city water line? Is there an air gap in the configuration you're describing?
Gosh, so that's the dilemma, right? So there's supposed to be an air, if there's an air gap, you can't have a valve that just changes it, right? So the Belimo valve on this specific situation, I think it's just a backflow preventer on this one. So I'll have to double check. My mechanical is not with me. I'm not the mechanical itself. I have my team too. So this specific one, I think it's just a backflow preventer.
Sounds good. We have another question here. I'm just going to read it out. Colored water would stain toilet bowls, creating complaints and negative use for water reuse. Do you polish your water with filters or chemical chlorine treatment? Also, how does cost of your square tanks compare against cylindrical tanks? This one's for you, Michael.
Yeah, absolutely. So what we're seeing, I guess, kind of low-hanging fruit here. If you have a ring in your toilet, it means your BOD is quite high. So what we're trying to mitigate with that is through our new designs of our biological treatment systems. And the cylindrical tanks versus our design, the cylindrical tanks, you have a situation where you have to almost outsource that through a third-party vendor. But if you go through us, we have all of the molds already produced, and we have a vendor already set up on our side. So the cost for a round poly tank versus our cost for the sectional tanks, what we provide for Aquacell, at this point it's quite minimal. So what we try and push for is to try and have our tanks just through ease of access and getting them into the different buildings. So, you know, I guess to answer your question, yes, it's minimal cost-wise.
Thanks, Michael. I had a question for all three of you. If you could, I know we have a number of designers, design engineers on the call, and I wanted to ask all three of you if you had to list your top #1 operational lesson learned to impart to a design engineer of an on-site reuse system in San Francisco, what would it be?
That's a great question. I think that from where I am, I think that the biggest thing is access to all of the piping, access to all of the valves, being able to walk in front of and behind. To be able to make those repairs is of high importance, when it comes to preventative maintenance and, dealing with breakdowns of equipment. I think those are really important things to consider when you're designing a system, is providing that space so that operators can easily access those things without having any kind of tripping hazards or things like that in front of them.
I would like to answer next. I agree with what you're saying, Ryan. But I think a lot of that stuff comes with the design phase. And what Aquacell has done is we're kind of a one-stop shop. Aquacell will design your system. They'll make sure that we're sized correctly. We'll manufacture your system. We'll send it to you. We'll commission it, and we'll service it. And having that luxury of the design, kind of what you were touching on, knowing where everything is, we're always a part of that at the very beginning stages. And I think that really speaks volumes moving forward to make sure that the PMs and everything are in place.
I agree with Ryan in regards to this space. Definitely, if the designers could see how we do maintenance on these systems, then that'd be key to designing it. But my number one thing is just having the building have water to the end use if I'm working on the system. So each building is kind of different. I don't think there's one solution, one like easy solution for each building, but that's my biggest issue I have that I think could definitely see improvement on.
I think footprint is a huge question. I think footprint is a huge thing. I mean, Kathy and Ryan, I think if we could have a footprint where we can put in what we wanted with no restrictions, we would have a system that would be completely optimized and 100% throughout the way. But that's just one of the things that we have to deal with, and one of the things that we're kind of talking about here tonight is just our lessons learned and how to move forward with what we can and working with what we have.
Absolutely. Another question for all three of you. Any suggestions for how to get these operational considerations adequately considered by designers and owners?
Yeah, I definitely think that open lines of communication in the design phase is really important. Epic has a team of engineers that are really, really good at layouts, really good at spacing. And I think that talking to industry professionals to be able to understand what the considerations are and what the factors are that go into layouts and footprints and designing tanks. I think the tank conversation is a huge one, because anytime that you can save space in a building, not only does it save the bottom line for the project, but it also opens up more for treatment systems and the footprint of the treatment systems. And, one of the things that Epic does really well is our system is designed to fit into tight spaces, into corners of buildings. But I think, having those open conversations and being willing to understand from industry experts and engineers is a great way to open that door to see how those operational considerations can be taken into account.
I think the hard part is the transition between like when a system is built and then the say the engineering group comes on board, the chief engineer of a building comes on board, and somehow there has to be a better way for the maybe certain manufacturers to be more accountable to handing it off in a working condition, I guess, or some systems are left like just sitting stagnant for so long. I think that's the hard part. But in regards to how to get the designers to see the insights, I think just stuff like this is a start, right? I mean, just to spread the word and just I guess, talk to each design firm and kind of spread what we're discussing today as a start.
Yeah, Kathy, I think you bring up a good point. The situation where you're in a position where the system's already there and then you're taking over the service and operations of it, we need to make sure that there's a clean cut there, and you know what you have and you know what it's capable of doing, and I think that's paramount too. So you made a really good point, and I think that's one of the things that we need to focus on to make sure that we're kind of all on the same page, and we're working with the engineering team that's on site to make sure that they're comfortable running a system. And one of those things that I've seen in the past is a lot of the building engineers want to make sure that everything is tied through the BMS. And if they have BMS access to it, they know exactly, they can come in the beginning of the day, they know exactly what's wrong with the system, they can do the walkthroughs. If there's any errors or anything, they have it right there on one screen. So I think that's a big point, and I appreciate you bringing that up.
Any other questions from the audience? Aha, one last one, and I'll let everybody go. Ryan, you shared that there are specific designs to mitigate odor with your products, then a secondary deodorize used as backup prevention for odor as well. And without revealing your company's trade secret, could you share what design schematics are included in your systems?
Yeah, great question. Thank you so much for it. So on the design front, I think ventilation is a really big deal. I've been at locations where the ventilation is inadequate. And so anytime that you have an overflow to a sewer or anything like that, odors can escape into the actual room itself. And, when you're down in the second basement, those odors can creep into an elevator shaft and, make their way up to lobbies and things like that. So I think those are really big considerations on tank design. So some of the things that we do is on the design end, and then secondary strategies, there is a variety. There's so many different ways that you can mitigate odor, but one of the best ways to deal with any kind of odor is to make sure that all of the lids are closed on your tanks, to make sure that all of the places where gases could escape are closed, and that your biology is healthy. I think this goes back to having a really highly trained operations staff, which we do here at Epic, that understand odors, they understand where they originate from, and they understand how to mitigate them. If your system is operating correctly and your biology is functioning properly, there should be little to no odors going out the effluent. And there are several other effluent side control strategies that we can deploy in order to deal with any kind of color or odor that's coming out of the effluent. But I will say my experience has been the vast majority of the systems that I operate, they have zero color or odor issues coming out the effluent, because again, the operation is efficient, the biology is healthy, and we've dealt with any potential leaks, spills, any escaping of gases. We've fixed ventilation systems, whatever needs to be done so that we're able to deal with that on from the design phase all the way through the effluent side.
Thanks, Ryan. Well, thank you again to all of our presenters today. If you weren't able to capture their contact information, I'm sure they can leave it in the chat, or you can contact me and I can get you in touch with these fine people. So with that, thank you so much for joining us for today's webinar. I hope you learned a lot, and take care.
Thank you, Taylor. Thanks for organizing this.
Thank you.